Hi, good evening. Good afternoon, sorry. Good afternoon, everyone. Am I audible? Are you guys able to hear me clearly? Okay, we'll start in 5 minutes. Let's others also join it. All right, guys, let's start anyway. I think that's all, you know, it should be. So, in the last session, we covered up cases, questions regarding the PNC, and now today we will be covering up things related to probability. And you see, most of the questions on probability involves the idea of PNC. So, if PNC is sorted, then probability is not a big problem. It's just that, the only difference when you can see a PNC question, being asked as a probability, you can always convert every PNC question into a likely probability questions. The additional thing that you need to do in case of a probability is to write it as a fraction of the possible case, the desired outcomes, the desired case to the total possible outcomes that you would get on that. Okay, so any question which involves solving about a PNC question. Okay, if it's written as a fraction over the total possible cases, it is simply the required probability that you have. Like if you would see, we were solving the questions of the word Paris and said, okay, in how many ways you can arrange them so that all the vowels are together. Okay, so if you remember, that way, so we had A and I kept together and we got the answer as 4 factorial into 2 factorial. Now, if that I divide by the total possible outcomes, which was 5 factorial. That becomes the required probability. So you can say that was a PNC question actually, you know, having the letters of the word Paris, having all the vowels together. So vowels together was AI and PRS that we solved to be 4 factorial, 2 factorial. Now if I divide this by 5 factorial, this is the required probability value for that. So if all the letters of the word Paris be rearranged, right, in all possible way, then what is the probability that all the vowels would be together? The required probability would be 2 on 5. Because 4 factorial will cancel with 5 factorial, leaving a 5, and 2 factorial is 2. So you would have 40% of them having the vowels together. Okay, that's how you can simply ask a PNC question as a probability, and that's what it is. Okay, so mostly we would more or less be solving it the way you do it with a more of a PNC approach, just that you need to divide it by the total possible cases that you have. That's the only difference that you'll have, right? Okay, so as we'll run through some very basic cases of the probability and then move on to more GRE type questions like we did in the previous class. So starting off with the first basic case on the probability, yeah, that's the definition. Favorable over total is the probability of an event. The minimum could be 0, the maximum could be 1. When nothing favors, then we say it's a okay impossible event. And when everything is favoring, the whole sample space, the whole experiment becomes your possible outcome. Right? So that becomes your 100%, which is your what you call as a certain event. If the probability is 50-50, then you call it as an equally likely event. If it is less than 50, you call it as less likely. And if it is more than 50, you call it as more likely. Okay, so these are some regular terms used in that. Now, the first and the easiest part, to begin with is cards. So there, you all will be familiar with 52 cards on the basis of colors divided into two types, blacks and reds. There are 26 each. Within each, you have two suits, two black suits and two red suits. The black ones are the spade and the club, and the red ones, they are the heart and the diamonds. Each suit comprises of an ace, the number cards from 2 to 10, and three face cards, which is jack, queen, and king. So overall, in total, there are four aces, 12 face cards, and 36 number cards. Right. So if a card is selected at random, what is the probability of drawing a queen from the deck? Okay, so what would be the required probability? There are four queens, okay, out of 52. So the required probability in this case would be 4 on 52, which is 1 on 13. Right, so you can see, selecting a one queen from the uh, the entire suit has the same probability as selecting one queen from the entire deck of cards, right? Because in either case, both the values gets multiplied by 4 times, so that gets cancelled out. So the required probability of selecting a queen from a particular suit, that a queen from that suit, whereas a queen from the entire deck is the same, right? So we say they both are equally probable events. The probability for both of them are the same, so they are equally probable events. That way. Okay, what would be the case if you know you draw two cards? One is a spade, the other is a heart. What is the answer? Yeah, what is the answer for this one? Are you guys able to hear me? Oh, okay. No, that's wrong. Why would you multiply it twice? 52 into 52, Ratmesh? Is it given that it's with replacement or without replacement? Yeah, that should be with the 52C2. Okay. Samyak, small mistake in there. Right. So if you look at it from two aspects, see, when you're drawing two or more cards, there are different ways. One is you select both at random, selecting, both the cards at random. So I might pick up both together at random, and then you can pick it one by one. If you pick it one by one, then there are two ways. You do it with replacement, you do it without replacement, right? So in the first case, you can do it with a replacement. In the second case, you do it without a replacement thing. Now, both together at random. Okay. Now, if you're solving it like this, okay, what is going to be the answer? Then your sample space in this case would be 52C2, and then there's 13 spade, 13 hearts, so 13C1 into 13C1 upon 52C2, which would simplify to 2 into 13 into 13 over 52 into 51, right? Now here, as you see, the 13 cancels 52 four times, 2 cancels 4 twice. That would reduce to 13 on 102, slightly less than 0.13. Right? If you round up to the nearest, you know, decimal, nearest hundredth, two decimal round off would give you that. Okay, so 13 on 102. Now, if you do it one by one with replacement, so you pick 13 over 52, and again 13 over 52. Right? So one spade and the other heart, but this should be wrong. Can you tell me what's wrong with this? One is a spade and the other is a heart. So you picked a spade, 13 upon 52, you place it back, then you select a heart, which is again 13 upon 52. So 13 upon 52 into 13 upon 52. If it is without replacement, so 13 upon 52, you take this spade, keep it aside. There are 51 left. Now you pick a heart from those 51, which is 13 over 50. So 13 over 52 into 13 over 51. Okay, now if you solve it like this, okay, you see all the three are different, right? But there's a catch. Okay, the second and the third one are not the correct answers. If you have solved it by replacement or maybe without replacement, 13 on 52 into 13 on 51, that's wrong. Can you tell me what's missing there in this case? Any hint why, you know, the without replacement case is wrong, or why, you know, the Samyuk's answer still is incomplete? Since the cards are different, you know, there are two ways of drawing it. So the correct answer would be into two in either case. Right. So it says one is a spade and the other is a heart. Doesn't mean that the first is a spade and the second is a heart. Out of two, you need one spade and one heart. So you can pick first spade and then a second as a heart. Or you can have the first one selected as a heart and the second one as a spade. Both are valid because there is no ordering which is given. So there's two ways of fixing or selecting a spade and a heart, right? Spade and then heart, or a heart and then a spade. In fact, if you would look at it, when you're picking in the first case at random, see, when you're picking both the cards at random, it's like you just pick two cards together. So their ordering doesn't matter which is the first or the second because you're picking both of that together. So that's what you get. But when you're doing it without replacement, you would see the probability same as this. So when ordering is not there, then the without replacement case is similar to the selecting at random. Given you multiply it, with all the possibilities given. Okay, and that's where it would be different. If the order is given, the first is a spade and the other is a heart, okay, then drawing at random doesn't matter because you need to follow the order. Then I cannot just randomly pick two. So this case will not exist. You have to simply follow this, and then the two won't come there. The first one has to be a spade, 13 on 52. The second one has to be a heart with replacement, which would be same, but without two and without replacement, 13 by 52 into 13 by 50. Right? So that would be different. Okay, so 13 on 102 is the right answer. Now let me change the question. Okay, if the question in this case is two cards are drawn from 52, right? Okay, one after one without replacement. Okay, what is the probability that one is a spade and the other is an ace? Okay, now try this. One is spade and the other is ace. Let's change the hearts to aces. Now check. Now tell me what will be your answer. All right, what is the answer with this? Just can be hearts too, yeah. Oh, oh, next one. 12C1 into 4C1 plus 1. No, this is 1 by 1 without replacement. So you won't have a 52C2. 13 over 204. Okay. So, as you see that the spades, oh no, and the heart in this first case was a mutually exclusive event. There's no card which is spades and heart, right? So they were empty, so they didn't affect. But as you see, spades and aces, they are not mutually exclusive. There's an intersection. So selection of one will affect the selection of the other. So we split into two cases. Case one, you know, when, you know, the spade that you draw, okay, let's say, make it more clear. The first is this, you're drawing a spade first and then an ace. Right. The product would be the same. Let's say, let's just take one case where you draw a spade first and then an ace. Now, in the first case, it matters which spade did you draw. Okay, was it an ace or it was uh, not an ace? Because if the spade was an ace of spade, then you will be left with only three aces for the second selection, as we've already removed that. It's without replacement. But if that spade was, let's say, a seven of spade, then you will have four aces left for the second selection. So we need to split into two cases. So case one, when the first one is not ace, not a spade of ace, which means there will be 12. So 12 over 52, right? And then we'll be left with 4. So 4 over 51. Okay. And the case 2, when it was spade of, it's an ace of spade. So there's only one ace of spade. So 1 on 52 into, there are only three aces left now. So 3 on 51. So therefore, you would see that your answer will be 12 on 52 into 4 on 51. Sorry, 52 on 51 plus 1 on 52 into 3 on 51, right? So 12 fours are 48, 48 and 351, 48 and 351. So 51 over 52 into 51 cancels out. So 1 on 52. Right? So you can say that 204, it's 52 into 4, right? 13 into 4 into 4. No, that will be too high, Sarang, for you. Okay, so you have to split that into two cases. Okay, now, as you would see, this is only one case, right? If you do the other, you have an ace first and then a spade. It's just going to give you the same thing. So you need to further multiply it by 2. As the order is not given in our case, so if the order is not given, then you multiply that by 2. So 2 over 52, which is 1 over 26. So that should give you 1 over 26. Okay, so if the order is given, the first is spade, the second is ace, then 1 on 52. Okay, and if the order is not given, then you can take either case spades and then an ace, or then ace first and then a spade, and then add. It is same. The probability won't change, It's just there are two ways of doing it. So twice, one not 52 and hence would change. Okay. All right. Now let's go to the next question. That's a dice one. So single dice, 6 outcomes. Two dice, 36 outcomes. This is what comes out of it. But you can just remember the pattern actually if you would see how the sum shapes up. So if you need the sum of two, that comes in only one way, 1 comma 1. This is a sum of three, which will come in two ways. Sum is 4, that comes in three ways. Sum is 5, comes in four ways. Sum is 6, comes in five ways. Sum is 7, comes in six ways. Sum is 8. So will not be 7, but it reduces now. The diagonal entry, the longest is 6, so now it starts reducing. 9, which is 4. 10, which is 3. 11, which is 2. 12, which is 1. So you see, 2, 3, 4, 5, 6, 7 max, and then reduces. So it's 1, 2, 3, 4, 5, 6, then 5, 4, 3, 2, 1. That makes a lot easier to remember than actually the whole series. So here, as you see, the sum has to be total of 8. Now, 7 is max, right? The diagonal entry is 7, which happens 6 ways, so 8 would be 5, right? So 5 on 36. You can get the answer directly. Okay, no need to solve that. You can just remember that outcomes in that. Okay, so now you have questions the way you see on the test. So let's try this one. Yeah, how much is that? 0.25. 0.25. How come? B, 0.2, right? So You want the sum to be equal to 9, right? So how many possible combinations in the denominator? From A, you need to select any one, so 4C1. From B, you need to select any one, so 5C1. And see how many combinations would give you a 9. So 5, 4, 4, 5, 3, 6, 2, 7. You won't get 8, 1. There's no 1 in that case. So there are only 4 cases. Right. So 4 over 4 into 5 cancels. That's 1 by 5. Right. So therefore, 20%. So that's 20% right now. Okay. So Pratmesh, I think you just made a silly mistakes. Of course, your method would be right. 4 by 16. Acha, okay. 4 into 4. Right. Then you'll get 25. Okay. All right. An easy question. Chalo, let's check this. All right, let's check. 1 minus 7 factorial into 4 factorial by 10 factorial. Yeah, perfect. So we use the complement method again. So 10 people need to be seated in a chair. Probability that, 4 particular people are never together. So it's the same thing as we did. Total minus together, the whole divided by, now this is a probability. So total, right? Because last time we saw it would be total minus together, which would be, the solving way we did for this type. But then it's a probability you have to divide by total. So that means the total on total would be 1 minus the together case on total, the probability of it being together. So that's why whenever you have to subtract the complement, you always take it from 1 when it comes to probability, whereas on a PNC it's always from the total number of possible outcomes. So 1 minus together, which is 4 particular together, so 4 and the other 6, so total of 7, and these 4 inside 4 factorial divided by 10 factorial. Now if you try to simplify this, so 1 minus 7 factorial cancels, this is 4 into 3 into 2, which is left on 10 into 9 and 8. So 4 and 2 cancels off with 8, 3 cancels 9 3 times. So this give us 1 minus 1 on 30. So the required probability is 29 on 30. Right? Perfect. Action 29 on 30. Yeah, all four need not be together. It doesn't say all of them separate. It could be one of the possible cases. So all the four are not together. Three can be, or two can be, or all of them may be separated. All cases included in this. Right? All I just don't want them, four of them, to be sitting next to each other. That's it. Right? Okay. Now moving on to the next one. Okay, a small change here. Of course, these are not the bottles. Okay, so replace it with balls. That's it. For all three, of course. Just the same thing. And then try. Okay, check. Okay, come, let's check the answers. What is it that we're getting for the first one? That's, it says randomly, right? So when you're picking it randomly, we have to write it down in terms of the NCR, or the replacement case multiplied by the total number of possibilities. Right, now we'll try to do that in either ways. So first one, all three are red, so three reds, so 3C3 on a total of 12C3, if I leave the answer in terms of that. Okay, and if we have to do it one by one, so three reds on 52 into two reds on 51 into one red on 50. Remember, all the three are reds. Okay, the same color balls are identical, so we will not multiply in this case with their arrangement, as this is like red, red, and red, so there is no rearrangement for them. No blue ball is selected. If there is no blue ball, so remove all the blues. It could be just a combination of green or red, so total of 8. So 8C3, pick anyone, doesn't matter, right, over 12C3, which in this case would be same as 8 upon 52 into 7 upon 51 into 6 upon 50. Okay, now in this case, should we multiply it by their rearrangement? Because it could be all three greens, right? Or three reds. Sorry. What I'm doing? My bad, my bad, my bad, my bad. Oh, no. Sorry, I'm just, my bad, mixing up. 12 and 11 and 10. 12, 11, 10. So just having that card wala thing in mind. Yeah. Right. So since it's done at random, so it makes more sense, of taking only the NCR approach. That'll be much more clear because, it's not said it's one by one without replacement and all that. And in the last one, okay, that we have here, in the last case, we don't want all them to be blue. Okay, some of the blues are allowed, not all of these should be blue. So you can, no, it says at random, right? At random means you're just putting your hands and picking all the three together. That is what you mean when you pick three balls at random. You're not picking the first and then the second and then the third. You just randomly, there's a box, you just go and pick all the three together. So the ordering doesn't matter here in any of the case, right? That's what. If it's with or without replacement, the question should clearly mention, three balls are picked, one after the other, with replacement or without replacement. Then you do that. Okay, so that's what the three cases we talked about, right? So you just need to identify which one it should be. So here it's all three together, so NCRs. And here in this case, not all are blue, so 1 minus all blue, right? So 1 minus 4C3 on a 12C3, right? So these would be the answers that you should learn. Perfect, right? Okay. So sorry about the 52 things. I was just having that, you know, the cards wala thing in my hand. Okay, let's try this. That's easy. It's a good question. Thoda tricky hai, be careful. Yeah, perfect. There are three cases, two cases in fact. All the three odds, could be odd, 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 or an odd, even, even. This is gonna be 1 by 2, the whole cube, because there are 100, of which 50, even 50 odd. So probability is 1 by 2 for each odd or even. For each ball to be odd or even. So 1 by 2 into 1 by 2 into 1 by 2, 1 by 2 cube. And in this case, it's 1 by 2, the whole cube again, but into 3. Because there will be three possibilities. First is odd, when the second is odd, and when the third is odd. So that's why into 3. So 3 by 8 plus 1 by 8, that's going to be 4 by 8, and hence the answer option would be C, 1 by 2. Right. Right. So that's it. So you could say, again, you can do it in a reduced case. Well, it's one way. Uh, if you get three evens, the sum would be even. If you get two evens and one odd, it would be odd. If you get one even and two odds, it's going to be even again. And if it's going to be three odds, it's going to be odd. So the chances of it being even and odd is these are the only four cases out of which twice the sum would be even and twice the sum would be odd. And hence the required probability would be 50-50. And hence you can directly say it's 1 by 2. You know, so it'll be the same thing. Right. So that is the case of reduced sample space. So you just use the idea of equiprobability bits. Okay, try this. Yeah, that's again a very simple, straightforward, right? 9 over 2000 or 3 over 40,000. The denominator would be huge, now 1000 into 800. And why 60? Oh, wait. Only one, right? There's only one pair. So, how many pairs can be formed? No, so this is gonna be only one pair. Okay. So there will be one pair. How many different combinations you can have for this forming one pair? It's gonna be 1000 C1, which is 1000 into 800 C1, which is 1000 juniors and 800 seniors. So you can pick one from the junior and one from the senior. So there are 1000 into 800 different possible combinations of this pair. Where you'll have one person from the junior section mapped with one from the senior. Now, out of these so many combinations, how many times it would happen that the pair, that combination for the pair actually turns out to be a sibling one. So you're going to see this as a pair combined, right? So you're going to see that there will be 60 such pairs, or I would say 60 such combination to form that pair where it turned out to be the real brothers or the real siblings. So it's going to be 60, not 60 into 60, right? So therefore, 60 over 1000 into 800. Because 1000 into 800 is a possibility of forming, one pair, which could be any junior linked with any senior. So this is the different number of ways in which you can form that pair. And out of those pairs, 60 of them, you know, are siblings. So therefore, 60 pairs out of total of these many pairs. And hence the required probability in this case will be, cancels on 2, 3 cancels 2 times, 2 cancels 3 times, 2 cancels 40 times. So 3 over 40,000. So should be 8. Don't take it 60C1 into 60C1. That's, that 60 is is a combination, is the answer to that combination, right? So therefore, as a pair that you will get. Or, you know, let's say how many juniors have their brothers in the senior section. So 60 juniors out of 1000 have a brother in the senior section. So, you can get a sibling pair only when you select a junior who has a brother in the senior one. Now, there's a probability of selecting such kid is 60 upon 1000. Now, this guy is going to have only one brother in the seniors. So, 1 into 800. You cannot multiply this by 60 again because this is one, this is the probability of selecting one junior who has his brother in the senior section, right? And he's going to have only one brother in the senior section. He's not going to have 60 brothers in the senior section, right? So therefore 60 on 1000 into 60 on 800 would be wrong. 60 on 1000 into 1 on 800, right? 60 on 1000 selecting a junior who has a brother and then selecting his brother. So it's only one brother, so 1 on 800. Is that clear? Okay, so that's why. So 8. Next, check this. Okay, this one was simple, straightforward. How much? 2 by 5? T 99 by 250. Oh. So let's say from 101 to 350. So how many numbers are there? I would say अगर 1 से कैलकुलेट करते तो 350 होते, उसमें से फर्स्ट 100 निकाल दिए तो कितने बचे? Only 250 बचे. Okay, so the only 250 of them, which should have a hundreds digits. So 200 to 299. So there are total of 100, not 99, because 200 is also counted, right? So when you subtract 99 and then plus 1, because you have to start with 200, no? So cancels on, 2 times 50, 5 times. So therefore 2 by 5, right? So just be careful, 99 plus 1. Don't forget to add 1 because you are including 200 as well, right? Okay, now check this. Okay, you have to find probability of B. Okay, check. Uh, it's displaying the answers, but you calculate and see if you're getting the answer as 0.4. Unfortunately, the answer is just coming at that point. What happened? Okay, now let's see. A union B is zero point 0.6, P of A is zero point 0.2, C union D is zero point 0.6, and P of C is zero point 0.5. It's given that the events are mutually exclusive. Now, as events are mutually exclusive, that means, A intersection B is empty. So there won't be any probability. The probability would be 0. So P of A union B, okay, as per the sum rule, would be just simply P of A plus P of B. You need to find probability of B. Now P of A union B is 0.6, which is equals to 0.2. plus P of P. Just take it on the other side. You get P of P as 0.4. This was a direct substitution. You know. Similarly, if you have to find P of D, again C union D, C and D are mutually exclusive, so C intersection D is 0. So zero point 0.6 minus zero point 0.5, 0.1, right? That would be the answer. Perfect. So it's 0.1. That's same. Okay, check this. Okay, check this. Okay, what about this? The product has to be positive, right? It's just like even odd case, no? And it doesn't matter which numbers you are choosing. So all four positive, you know, it would be positive. So 8C4 on 18C4, or two positive, two negatives. 8C2 into 10C2 on 18C4, or all four negative, right? We want the product to be positive, which is 10C4 on 18C4, right? So 8C4 plus 10C4 plus 8C2 into 10C2 over the whole 18C4. Just check whatever it reduces, so that would be the answer. Yeah, perfect. Good. Next one, 0.503, right? Okay, check this. One minus, it is not solved. So you can say, so when you say the problem would be solved, doesn't mean it has to be solved by all three of them. If at least one of them solves it, the problem will be solved, right? So whenever you have an at least one case, it's always one minus none. So 1 minus fails 2 by 7, fails 4 by 6, fails, in this case, that would be a 9 on 12. So 4, 3 times, and then 2, 3 times, and 3 and 3, 9. 1 minus 1 on 7, 6 and 7. Right, E, perfect, E is there. Okay, so it's an at least one case. So for at least, it's always 1 minus none. That's the shortest and the fastest route. Okay, check this. This is direct. So 10 would be, third last. So 1, 2, 3. 3 on 36. It's 1 on 12. Remember the table. The outcome goes 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. These are the number of outcomes in which the sum from 2 to 12 can be obtained. So 10th is the third last, right? So reverse, it would be 1, 2, 3. So 3 from the last, and hence 3 by 36, which is 1 by 12. Okay, the sum on the two dice is at most 10. That is when getting a 10. Okay, all right, sorry, you want it as at most 10. So at most 10 means, let's take the complement first. There will be cases. So 2 to 10. So 11 and 12. So we want at most 10, this one. Okay, 11 and 12, the 11 will come in two ways and one way. So 3, right? 3 by 36, which is 1 by 12. So therefore 11 by 12. 1 minus 3 by 36, right? So you don't have to add up all of these, okay, from 2 to 10. You just take the complement 11 and 12, which is easy, and then 1 minus that, yeah, which is 11 by 12. Correct? So 1 minus 1 by 12, that's 11 by 12. Oh, that was in fact the last question. Okay. So we're done with that. Oh, that's quick. Okay, guys. So we finish up with the PNC and probability session today. I'll just update you on the the revision part. So some of the session that were we had a low attendance and we ended up canceling, or that we had very low attendance. So in case if we have to repeat, and once we are done with that, we can start with the more advanced set of question sets from there. So there would be a second revision where we will complete. Samyak, good. You reminded me. What I'm doing is I'll mail you. I'm gonna mail Samyak all the files, because if I there's too many IDs. So Samyak, can you just do one thing? I'll mail you all these books, and maybe what you can do is you can make a drive folder for it, and then just share the link of the drive with everyone. So then you will also have it. It's not just only these few. You can just post it on your group, and anyone who wants to use it, your personal WhatsApp group, you can be used. So I'm gonna send you all these books because it's heavy. So it's sometimes they don't get into the mail and all that. So I'm gonna send you by today or tomorrow at max, and then you just upload it on the drive and share the link to the drive folder with everyone on the group. Yeah, that would be done. It's just a day's thing. Mail drop. I'm not using a mail. What is it, an app or it's some site? Not much worse with that. I'll check. I'll just go and Google it out and see what it is, and then maybe if it is, then I'll send it to you across that. Not a problem. Achha, okay, just like share it. Okay, it's just like a share it thing. Okay, okay, take it. I'll try to do that. But I'll get this thing done sorted by tomorrow itself. Okay, sure. See you guys next week. Okay, take care, stay safe, study well. Bye bye.